Hi, I'm Hunter, and today I'm going to teach you about the first derivative test. So, what we're going to do today is derive our function, set it equal to 0, and then use the first derivative test to find the maxes or mins. So what we're going to do is we're going to create a curve by having Michael jump off the swing. So this is the swing set that I jumped off of. And this is the graph of the path that I took when I jumped off the swing set. And the graph here is modeled by the function f of x equals x cubed minus x. Now we're going to use the first derivative test to find the x values at which the maximum or minimums occur in this graph. So now we're going to take this function and move it to the center. And then we're going to take the derivative of this function and set it equal to 0. Now we use simple algebra to solve for x, and we use the first derivative test to find out maxes and mins. Now we take these x values and we're going to set up 3 intervals from here, here, and here, and we're going to test values from within these intervals. We're going to take values that fit within these 3 intervals, and we're going to plug them into the derivative equation. And we're going to see if they come out positive or negative to determine the maxes and mins on this function. So the values that we picked are -1, 0, and 1. And we're going to plug these into the derivative equation and see what we get. By plugging in the values into the derivative, we end up with a positive value for the -1 interval, a negative value for the 0 interval, and a positive value again for the +1 interval. So what you can tell from all this data is that in between the first 2 intervals there is a maximum, and in between the last 2 intervals there's a minimum. And if we look at the graph, we can verify that the maximum is at negative radical 1/3, and the minimum is at positive radical 1/3. And that is the first derivative test in action.